Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be working out practice problems from the fourth full-length practice test on my website. If this is your first time finding my YouTube channel, I quickly want to mention that I recently created a small website called ASVABApp.com. There you can take 7 practice tests in total, 3 of which are short practice tests and 4 of which are full-length practice tests. And as it happens, all of them give you a rough estimate of your AFQT score. In light of that, I recommend that you go to my website and take this practice test. Otherwise, if you're going to use YouTube to complete this practice test, I strongly encourage you to pause the video after I read each question, attempt to work out the question on your own, and then resume playing the video to check your solution. On the ASVAB, you're not going to be permitted to use a calculator or a reference sheet, so as you complete this practice test, make sure not to use any of those resources. As usual, I'm going to include timestamps in the description of this video. Those timestamps are going to be associated with each question. More specifically, the timestamp's going to be about the topic the question's testing. And next to the topic, there's going to be a link to a video where I discuss that topic in greater detail. So if at any point you feel as if you need more help, check the description of this video, and there you'll find those additional resources. So all that being said, let's go ahead and get started with today's video. All right, number 1 says the expression 6 factorial, or this exclamation point means factorial as well, so 6 factorial means. Well, to do this one, you have to know what factorial means, and that's defined as the product of an integer by all the integers below it. So this 6 factorial is the same as 6 times 5 times 4 times 3 times 2 times 1. 0 is not an integer, so we wouldn't include that. So by working this out here, we'll know what 6 factorial is. So let's go ahead and do that. Fortunately enough, this is pretty easy to do. We have 6 times 5, which is 30. Then we have 30 times 4. 3 times 4 would be 12. Therefore, 30 times 4 is 120. Now we have 120 times 3. If you can't do that mentally, it's always a safe bet to work it off to the side like this. Sometimes I do stuff like this mentally, and sometimes I work it off to the side. Depends on how I'm feeling that day. So we got 0 times 3, which is 0, 2 times 3, which is 6, and 1 times 3, which is 3. So 120 times 3 is 360. Then we're going to multiply that by 2. Likewise, you should be able to do that mentally, but if you want to play it safe, you can go ahead and do that off to the side here. 0 times 2 is 0. 6 times 2 is 12. Carry a 1. 3 times 2 is 6. Plus 1 is 7. So 360 times 2 is 720. 720 times 1 is just 720. Again, anything times 1 is just itself. So 6 factorial here is 720. Believe it or not, these problems get a little more challenging. So in my video on factorials, I actually work out problems like this. I'll give you something like 5 factorial times 2 factorial over 3 factorial. Again, if you want more practice using factorials, check out that video. But as long as you know that factorial is defined as the product of the integer by all the integers below it up until 1, you should be set for the ASVAB. All right, number 2 says the reciprocal of 9 to the nearest thousandth is. So let's start with what we're given. We want to find the reciprocal of 9. Well, the reciprocal means you just take a number and you flip it. But if we look at 9, we might be saying to ourselves, well, what am I going to flip here? It's just 9. Well, technically, all whole numbers can be written as fractions by placing them over 1. And once you do that, you can find the reciprocal pretty easy. Again, you're just going to exchange this 9 with this 1. So the reciprocal of 9 over 1 is just 1 over 9. We just flipped it. Now, the tricky part about this problem is it wants you to round it to the nearest thousand. Well, you also have to know that fractions can be treated as long division. So in other words, this can be read as 1/9 as a fraction, or you can read it as 1 divided by 9, which is what we have to do in this case. So we're going to start by asking ourselves, how many times does 9 go into 1? And since it doesn't, we're going to have to add a decimal here and a couple of 0 placeholders. Again, in case this isn't obvious, 1 is the same as 1.00000. In other words, those zeros don't affect the value of 1, but they give us the ability to perform this long division here. Once you add that decimal here, you can bring it up right here. And now that we've added that decimal, we can disregard this decimal down here. So we wouldn't read this as 1.000. Instead, we would read this as 1,000. Okay, so that's an important thing to note. Now the question is, how many times does 9 go into 10 without going over? Well, 9 times 1 is 9. 10 minus 9 is 1. And now we can drop down a 0. How many times does 9 go into 10 without going over? That's 1 time. 9 times 1 is 9. 10 minus 9 is 1. Now we can drop down this 0. How many times does 9 go into 10 without going over? That's 1 time. 9 times 1 is 9. Again, we have as many 0 placeholders here as we need. And we can drop down 0 placeholder here. 10 minus 9 is 1. With our 0 placeholder there, 9 goes into 10 1 time without going over. 9 times 1 is 9. And we have enough to round this to the thousands place. Again, we have this so far, 1, 2, 3, 4. This right here is our tens place, hundreds place, thousands place. So we want to round right here. To round, we're looking to the number to the right. And if it's 4 or below, we're keeping this number the same. If it's 5 or above, we're rounding up. And if we look to the right, you can see we have a 1. So this is just going to round to 0.111, which is answer choice B. A difficult problem if you don't know that whole numbers 1 can be written as fractions by placing them over 1. And 2, fractions can all be converted to decimals via some simple long division. So that's that one. All right, number 3 is one of my favorite problems because it tells you exactly what to do. Number 3 says, what is 5% of 0.0125? So what I like to do for this one is write it as a expression up top, and then I'll write it over here so I can do the work. What is? So x is 5%. Well, 5%, we're always going to put that in decimal form, so it's going to be 0.05. In math, of means multiply, so this is multiply 0.0125. Okay, so what is 5% of 0.0125 is the same as x equals 0.05 times 0.0125. So let's go ahead and write that out over here. X equals 0.05 times 0.0125. And in my video on percents, I discuss how you can convert these word problems into algebraic expressions pretty easily. But in this case, we're just doing multiplication involving 2 decimals here. And the key to doing this is to write them off to the side like this. We have 0.0125 times 0.05. And now we want to shift the decimals such that we get rid of the decimals in both 0.0125 as well as 0.05. And I'm going to take note as to how many times it takes to get rid of those decimals or clear those decimals. So we're going to shift the decimal 1, 2, 3, 4 times here and 1, 2 here. That's going to enable me to rewrite these numbers without decimals. So this is going to be 125 times 5. And we're going to have to, once we work this out, shift our decimal place 6 times back to the left once we're done. And again, I move the decimal places 6 times to the right here. 4 plus 2 is 6. So I have to shift it 6 times to the left here. All right, so let's work this out now. 5 times 5 is 25, so we're going to drop down a 5 and carry a 2. 5 times 2 is 10, plus 2 is 12, so drop down a 2, carry a 1. 1 times 5 is 5, plus 1 is 6. And now we're going to take our decimal place, which is right here technically, and shift it 6 times to the left. So that's going to be 1, 2, 3, 4, 5, 6. In these empty spaces, we fill in 0 placeholders, so we're going to need 3 of them. So in other words, 5% of 0.0125 is 0.000625, which, as it turns out, is answer choice C in this case. Okay, so that's that one. All right, number 4 says, what number multiplied by 1 over 12 will result in a product of 1? So this one's very explicit in telling you what to do. What number, let's call that n, multiplied by, well, that's multiplication, by 1 over 12, will result in is equal, a product of 1. So this word problem in an algebraic expression is n times 1 over 12 equals 1. That said, let's go ahead and clean it up a little bit. We can write this as 1 over 12 n equals 1. So as you can see, we're just solving for n at this point, so we want to clear this 1 over 12 from the left. And in order to do that, we're going to multiply it by its reciprocal, notably 12 over 1. And we're going to do that to both sides. Let's take a look right here. This 12 and this 12 crosses out, and this 1 crosses out. So 1 over 12 times 12 over 1 is just 1. This leaves us with 1 times n, and anything times itself is just itself. So 1 times n is just n. And again, this 12 over 1 is the same as just 12. So in reality, 1 times 12 over 1 is the same as 1 times 12. 1 times 12 is just 12. So we can see the answer to this one is n equals 12, which is answer choice A. So that's that one. Again, it tells you exactly what to do. And as long as you know how to clear up fractions, this one should have been pretty easy and straightforward. All right, number 5 says, solve the following expression for x. We have 2/3 x minus 5 equals x minus 3. So let's go ahead and copy this one down as if it was on our own scratch paper. So we have 2/3 x minus 5 equals x minus 3. So when you have to solve for x, your goal is to get all the x's on one side and everything else on the other side of the equal sign. So the very first thing I want to do is move this 5 over here. This will cross out, leaving you with 2/3 x equals x. Negative 3 plus 5 is positive 2. All right, now we want to move this x over here. So we're going to subtract x from both sides. This will cross out here, leaving you with just 2 on this side. And this is a pretty challenging question here. This says 2/3 x minus x. Well, you have to know that technically there's a 1 here. That's 1x. So let's work this off to the side. Again, we have 2/3 minus 1. 2/3, let me fix that 3 real quick, minus 1. The very first thing you have to realize is that to subtract fractions, they have to have the same basis. And as you may recall from the earlier problems in this video, I can rewrite this 1 as this, 2/3 minus 1 over 1. And now we have to find a common denominator for 3 and 1 such that we can write both or one of these fractions with the same denominators. Well, 3 and 1 have a common factor of 3. So this is going to be 2/3 minus, again, we want to write 1 such that it has a denominator of 3. So we're going to multiply it by 3. We're also going to do that to its numerator. 1 times 3 is 3. 1 times 3 is 3. Now that these fractions have the same denominators, we can just subtract their numerators. So this becomes 2 minus 3 over 3. 2 minus 3 is negative 1 over 3. So 2/3 x minus 1x. is the same as negative 1/3 x. And now we have to clear this negative 1/3 in order to just solve for x. So we're going to multiply it by its reciprocal. The reciprocal of negative 1/3 is negative 3/1. And we're going to do that to both sides. Again, this will cross out here and here. A negative times a negative is a positive. So this just leaves you with x. And right here, we're doing multiplication involving fractions. Let's write 2 as 2/1, which will enable us to multiply straight across. This becomes 2 times negative 3, which is negative 6, over 1 times 1. Negative 6 divided by 1 is just negative 6. So the answer to this one is D, negative 6. Again, you have to be good with fractions to be successful on the ASVAB. More specifically, you have to know that multiplying a fraction by its reciprocal results in just 1. And we saw a problem regarding that earlier in this video. All right, number 6 says, solve the following system of equations. We have 5 equals x plus y and 2y plus x equals 7. So let's just copy this one down to start. We have 5 equals x plus y, and then we have 2y plus x equals 7. So this one's a little jumbled up. Again, normally you want the expression to look like this. X plus y equals some whole value, like 5. So I'm going to have to rewrite, as you can see, both of these in order to get them in that form. For this one, it's pretty easy. We're just going to move this x plus y to the front. So this becomes x plus y equals 5. And for this one, we're just going to flip-flop the x and y position. So this becomes x plus 2y equals 7. Okay, so now that these are in this form, we're going to either use the substitution or elimination method in order to get rid of one of these variables. And once we do that, it's going to be pretty easy to solve for the other variable. So according to the elimination method, you're either going to multiply one or both these equations by a constant, such that when you add both the equations together, one of the variables is eliminated. Well, if I multiply this top equation by a negative 1, you'll see that when I add negative x to positive x, that variable is eliminated. So let's go ahead and do that. And I'm going to write that off to the side here. Again, we're taking this negative 1 and multiplying it here, here, and here. So negative 1 times x is negative x. Negative 1 times y is negative y. Negative 1 times positive 5 is negative 5. Then we're just going to copy down this second equation, x plus 2y equals 7. And as I mentioned, we're going to add them together. And in doing so, we can see that negative x plus positive x is eliminated at 0. Negative y plus 2y is just y. And negative 5 plus 7 is 2. So we've solved this equation for y. And in order to solve this equation for x, we're going to take this value of y and plug it into one of our two original equations, either this one or this one, and then solve for x. So let's go ahead and copy down this original equation here. We have 5 equals x plus y. Again, we now know y is 2. So in place of y here, we can substitute 2 in. This becomes 5 equals x plus 2. Again, we're just solving for x at this point, so we're going to subtract 2 from both sides. This crosses out, leaving you with x equals 5 minus 2, which is 3. So if your solution's not written as x equals 3, y equals 2, you have to write it as an ordered pair. So this would be 3, 2. And in an ordered pair, in case it's not obvious, your x comes first, your y comes second. So this is 3, 2, which is answer choice B. You will almost certainly see a system of equations on the ASVAB, so make sure you know how to do those. Again, in the description of this video, I think I have 2 or 3 links to videos on solving systems if you need more help. All right, so for number 7, it says write the equation of the line that passes through the point 1,6 and point 3,2. So let's just copy down what's given before we get started. Again, we're given the points 1,6 and 3,2, and we're being asked to write an equation of a line that passes through these 2 points. So what I'm going to do is label these. I know this is x1, y1, which makes this x2, y2. The next thing I'm going to do is try to figure out what the slope of the line is that passes through these 2 points. And we can use the slope formula to do that. That's m refers to slope, equals y2 minus y1 over x2 minus x1. Where do we get y1, y2, x1, x2 from? There are values of our ordered pairs, which I just labeled for you. So this becomes m equals y2, which is 2, minus y1, which is 6. x2 is 3. x1 is 1. Let's keep working this out. 2 minus 6 is going to be negative 4. 3 minus 1 is 2. Negative 4 divided by positive 2 is negative 2. So I know the slope of our line is negative 2. And if we look at our answer choices, they're all of this form. Y equals mx plus b, where again, m is the slope. We know the slope of this line is negative 2. This slope's negative 2. This slope's positive 2. This slope's positive 2. This slope's positive 2. So by process of elimination, I already know the correct answer choice is going to be A. But that said, let's keep working this one out. Now that we have the slope, we're going to plug it as well as one of these ordered pairs into the point slope equation, which is this. Again, it's y minus y1 equals m times x minus x1. And don't think that because I was able to solve this one pretty quickly without having to do this part here, you'll see that on the ASVAB. Chances are on the ASVAB, you're going to have to solve this one fully. So just don't stop watching this video when you get to this answer. All right, so we know what m is. M is right here. It's negative 2. We know what y1 is. It's right here. And we know what x1 is. So let's plug those in. This is y minus y1, which is 6, equals m is negative 2, times x minus x1. It's right here. It's 1. All right, the next thing we want to do is distribute this 2 to this negative x and this negative 1, or to this x and negative 1. So this is y minus 6 equals negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. Let's go ahead and add 6 to both sides now. This crosses out, leaving you with y equals negative 2x. 2 plus 6 is 8. So this says y equals negative 2x plus 8. This is in fact an equation of a line that passes through these 2 points. And as we can see, that does in fact match answer choice A. Okay, so a good example of a problem that may show up on the ASVAB. You'll be given 2 points and asked to write the equation of a line that passes through both of them. All right, number 8 says solve the following equation for x. We have x squared plus 15x equals negative 50. So we have x squared plus 15x equals negative 50. The very first thing I'm going to do is set this equation to 0. So I'm going to add 50 to both sides, just like this. This will cross out here, leaving you with 0 on this side, and this says x squared plus 15x plus 50 equals 0. Now that I've rewritten this equation such that it's equal to 0, I can solve this one by factoring. And when you factor a quadratic that has a leading coefficient of 1 here, again, technically there's a 1 right here, it's going to be of this form, x times x in parentheses. And now we're looking for 2 factors that multiply to 50 and add to 15. Well, that's pretty easy to do. 10 times 5 is 50. 10 plus 5 is 15. So our 2 factors in this case are going to be 10 and 5. And now that we've factored this one, to solve for x, we have to break these apart and set them both equal to 0 individually. So this becomes x plus 10 equals 0, and x plus 5 equals 0. To solve for x here, we're going to subtract 10 from both sides. This will cross out here, and this says x equals 0 minus 10, which is negative 10. Likewise, to solve for x here, we're going to subtract 5 from both sides. This crosses out here, leaving you with x equals 0 minus 5, which is negative 5. So our answer to this one is x equals negative 10, x equals negative 5, which is answer choice D. Again, you had to factor it, and then after that, you had to break your factors apart and set them both equal to 0 in order to solve for x. Number 9 says the radius of a circle is 35 meters. What is the circumference of the circle? Use 22 over 7 for pi. So on the ASVAB, you're going to either approximate pi as 3.14, or if the problem specifies, you're going to use 22 over 7. But that said, let's draw a little diagram to see what's going on here. Again, we have a circle here, and we know its radius is 35 meters. Again, radius is defined as the distance from the center point of the circle to the edge of the circle. So in this case, I know that distance right there, according to the problem, is 35 meters. And again, I can put an R there to specify that that is in fact the radius. All right, now we're trying to find the circumference of this circle. Circumference is given by two formulas. It's either pi times diameter or 2 pi r. I like to use pi times diameter, but if you're only given radius, you can always plug that value in here and work it out accordingly. Since we were only given the radius, let's just use this formula here. Circumference equals 2 pi r. We know what r is, it's 35, so circumference equals 2 pi times 35. I'm going to work this out very quickly. Off to the side, I'm going to do 2 times 35. 35 times 2 is what? 5 times 2 is 0, carry a 1. 3 times 2 is 6, plus 1 is 7. So this becomes circumference equals 70 pi. According to the problem, we're supposed to use 22 over 7 for pi, so now let's plug that in. This becomes 70 times 22 over 7. All right, so you can work this out the long way if you want, but that said, I'm going to rewrite 70 as 70 over 1, because in essence, we're multiplying two fractions here. And what's more, I'm going to cross out this 7, because I know 7 goes into 7 one time, and it goes into 70 10 times. So this becomes circumference equals 10 over 1. Anything divided by 1 is itself. So that's 10 times 22 over 1, which is just 22. And you might be saying to yourself, well, do I have to work out 22 times 10 like this? You could if you wanted to, but 10 is a power of 10. Again, powers of 10 are 10, 100, 1,000, 10,000, and so on. And whenever you multiply a power of 10 by anything, the math is very easy to do. In 22, there's technically a decimal here. And since we're multiplying it by a power of 10, all we're going to do is take its decimal and shift it to the right according to how many zeros there are in our power of 10. In 10, there's 1 0, so we're going to shift our decimal one time to the right and add in a 0 placeholder. So this is 220, and our answer, therefore, is 220 meters. C. Okay, so that's that one. Nothing too difficult. A lot of people would get stuck again working with the fractions, but again, fractions are very easy. On my channel, I have 4 videos regarding fractions now. So if you can't work with fractions yet, you need to go watch those 4 videos. And after you do that, you should have no problem working these out pretty quickly. All right, number 10 says solve the following inequality for x. We have 2 times x minus 5 in parentheses, less than or equal to 14. So not surprisingly, I'm going to copy this one down as if I was working it out on my own scratch paper. We have 2 times 5 minus x less than or equal to 14. To start, we're going to take this 2 and distribute it here and here. So 2 times 5 is 10. 2 times negative x is negative 2x, less than or equal to 14. Now that we're solving for x, we're trying to get x by itself. So the very first thing I'm going to do is subtract 10 from both sides. This is going to cross out here, leaving me with negative 2x is less than or equal to 14 minus 10 is 4. All right, so the trick to inequalities is this. You can add and subtract across this inequality sign with no problems. But as soon as you multiply or divide across the inequality sign by a negative, that prompts you to flip the direction of the sign here. So watch this next move very closely. To get rid of this negative 2 in front of this x, I'm going to divide both sides by negative 2. I just divided across the inequality sign by a negative. So the very first thing I'm going to do is flip the direction of the sign. This crosses out here, leaving you with just x. And this says 4 divided by negative 2, which is negative 2. So the answer to this one is x is greater than or equal to negative 2, which is answer choice C. Again, if you multiply or divide across the inequality sign by a negative number, that prompts you to flip the direction of its sign. But that said, you can subtract across it all day. All right, so that's that one. All right, number 11 says find the mean, median, mode, and range of the following data set. We have 4, 5, 1, 7, 6, 5, 3, 5, 4, 5, 3. So the very first thing you want to do is take the numbers that you're given and rearrange them such that they're from least to greatest. So that's what I'm going to do to start. Again, we have a 1 here. Let's cross it off as we do it. 1. Then after that, we have 3, which appears twice. So we'll do 3 next. After that, we have 4, which also appears twice. So we'll write down our 2 4s now. Then we have 5, which appears 1, 2, 3, 4 times. So that's 5, 5, 5, 5. Then we just have 6 and 7. All right, so we've rearranged our data set from least to greatest. And now that we've done that, it's going to be much easier to work this problem out. In case it's not obvious, these answer choices are written in the same way that the problem asks you to find these things. So right here, this first number is going to be your mean. This next term, or this next number is going to be your mode. This next number right here is going to be your, oh, I take that back. You have your mean, median, mode, and then finally your range. And I'm going to work backwards because it's easier to find the range than it is to find the mean. So let's go ahead and do that first. And since we ordered this from least to greatest, the range is very easy to find. It's going to be this last term minus your first term. In other words, it's 7 minus 1. 7 minus 1 is 6. And if we look through our answer choices where the range is, we can see that they are all 6. So that doesn't help. Let's move on to the mode. The mode is the number that appears the most often in your data set. And as I crossed off these numbers, you may have recalled that I mentioned that all these numbers appear 2 or fewer times except for 5. 5 appeared 4 times, so our mode in this case is going to be 5. All right, let's find the median next. Again, if we look through our answer choices, we can see they all have a mode of 5. So that doesn't help us in terms of solving this one quickly. To find the median, you cross off numbers 1 at each end until you get either to the middle term or the middle 2 terms. And let me explain that. If you have an odd number of terms, there's only going to be one median in your data set. And in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 terms. So when we cross off numbers 1 at each end, we're only going to have one term in the very middle. If this was an even number of data points, we would have two numbers in the middle, and we would have to find the average of those two numbers in order to find our median. So let's start crossing these off, one at each end, one there, 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 one there. And not surprisingly, we only have one number in our as the median. So our median is 5 in this case. And if we take a look through our answer choices, we can see that all those medians are in fact 5. So now we're going to have to calculate the mean. And to find the mean, you sum all the numbers and divide by how many numbers there are. So that looks like this. 1 plus 3 plus 3 plus 4 plus 4 plus 5 4 times plus 6 plus 7. And as I mentioned, there are 11 terms in this data set. So to find the mean, we're going to have to work this out. And whenever I have to sum a large set of numbers like this, I usually do it vertically, but these numbers are pretty easy. We have 4 times here. 5 times 4 is 20. 6 plus 7 is going to be 13. 4 and 4 is 8. 3 and 3 is 6. 6 plus 1 is 7. Let's keep doing this. We have 13 and 20, which is 33. And 7 and 8, which is 15. Let's go ahead and do this off to the side to get this number, 33 and 15. 5 plus 3 is 8. 3 plus 1 is 4. So we can see that the sum of all these terms is 48. So the mean is 48 over 11. And thankfully enough, that is one of the means in our answer choices. So the answer to this one is 48 over 11. Okay, so that's that one. All right, number 12 says the area of a square with a perimeter of 60 inches is. So we know we're dealing with a square, so let's draw a square. And what do we know about squares? Well, squares have all equal sides. And those bars I just drew said this side's equal to this side's equal to this side. All the sides are equal in a square. What's more, we're told the perimeter of this square is 60 inches. Well, how can I use this information about all the sides of a square being equal and the perimeter being 60 inches to find the area? Well, if all the sides are equal and I let one of the sides be x, that means all of the sides are x. And in order to find the perimeter of any quadrilateral, you simply add up all the sides. So the perimeter of this square is just x plus x plus x plus x. We know what p is. We were told the perimeter is 60. So in place of p, I'm going to write 60. Again, this is x plus x plus x plus x. Let's combine these like terms. We have 4x's, so this is 4x equals 60. Let's get rid of this 4 by dividing both sides by 4. This crosses out here, leaving you x on this side. Let's do 60 divided by 4. 4 goes into 6 one time without going over. 4 times 1 is 4. 6 minus 4 is 2. Drop down this 0. 4 goes into 20. 5 times 4 times 5 is 20. So in other words, 60 divided by 4 is 15. And we know x is 15 now. All right, so we know x is 15. So we know we're dealing with a square like this. It's a 15 by 15 square. Again, x is here, x is 15, x is 15. To find the area of a square, it's simply side times side. And we know what the sides of the square are. They're 15 all the way around. So the area is side by side, which is 15 times 15, or 15 squared. But you should know especially if you looked at my reference sheet that 15 squared is 225. So the area of this square is 225 inches, and that should be squared there. But in case you couldn't work this out mentally, I'll work it off to the side for you very quickly here. 5 times 5 is 25, carry a 2. 1 times 5 is 5, plus 2 is going to be 7. Before you start multiplication with this 0, add this 1, add a 0 placeholder. 1 times 5 is 5, 1 times 1 is 1. Add these together, 5 plus 0 is 5. 7 plus 5 is 12, carry a 1. 1 plus 1 is 2. Okay, so that's that one. Nothing too difficult there, just some simple logic as well as some simple algebra. All right, number 13 says the points A, 2, 3, and B, 0, 6 are plotted on a coordinate plane. What is the distance from A to B? So for this one, we have to know the distance formula, which is given by this formula, x2 minus x1 squared plus y2 minus y1 squared. Again, where do we get x2, x1, y2, and y1 from? Those are the values from our ordered pairs. Again, we have this ordered pair 2, 3, and this ordered pair 0, 6. Call this one x1, y1, x2, y2. Now all we do is have to plug those values in. We have x2, which is right here, 0 minus x1, which is 2. That's going to be squared. Y2 is here, 6 minus y1, that's here, that's 3 squared. All right, let's keep working this out. 0 minus 2 is negative 2 squared plus 6 minus 3, that's 3 squared. This is negative 2 squared, which is the same as negative 2 times negative 2, which is 4, plus 3 squared is going to be 9. 4 plus 9 is 13. So the distance between A and B, as we just saw using the distance formula, is the square root of 13, which is answer choice D. Again, this is one of the formulas on my reference sheet, and I recommend that you memorize it. It's not that hard to remember, but that said, this is one of those problems where if you know the formula, it's a very easy problem. If you don't know the formula, you're kind of up a creek without a paddle. So make sure you look at that reference sheet. Personally, I'd recommend that you take my reference sheet and copy it down in your own writing in your notebook. And that simple act of copying down my reference sheet in your own writing is going to help you memorize most of those formulas. All right, number 14 says simplify the expression. We have 15x to the third y squared times z over 5 times xyz. So let's go ahead and copy this one off to the side. We have 15x cubed y squared times z over 5xyz. All right, so for this one, we're going to have to know the laws of exponents in order to simplify this. That said, we're going to take it one thing at a time. We're going to deal with these whole values first. Then we're going to look at these x's, these y's, and these z's. The very first thing you should realize is that 15 divided by 5 is 3. Okay? And we've gotten rid of those whole values now. As far as reducing these x, y, and z's, we have to know one law of exponent, notably the quotient rule. And the quotient rule says this: if you have a to the m over a to the n, that's the same as a to the m minus n. If we take a look at our x's here, we have x to the third over x, and if you don't see an exponent, you can always write in a 1 to make it a little bit easier. So we have x to the third over x to the 1. Again, our bases are the same. They're both x. So that tells us we can subtract our exponents. So this becomes x to the 3 minus 1. If we do the same thing with the y's, we can see that we have y squared over y to the 1. That's y to the 2 minus 1. And then finally, we have z to the 1 over z to the 1. So that's z to the 1 minus 1. Let's go ahead and work on simplifying this. This becomes 3x to the 3 minus 1. 3 minus 1 is 2. Y to the 2 minus 1. 2 minus 1 is 1. Whenever an exponent's 1, you don't have to write a 1 there. Again, it's implied that it's 1. Then here we have z to the 1 minus 1. That is z to the 0. Anything raised to the 0 power is always going to be 1. Okay? So this becomes times 1. In light of the fact that anything times 1 is just itself, we can actually get rid of that 1. So this is 3 to the x squared y in simplest terms, which we can see is answer choice D. On my channel, I do have a video about the laws of exponents. I believe there's 6 of them that you have to know. They're not that difficult, and I think in that video I do like 40 or so practice problems. So if you need more help with this, check out my video on the laws of exponents. Again, unlike a lot of YouTubers who just put out one video that's about 5 minutes long and they do the easiest problem, I work from the easiest problem to the hardest problem. So you're going to get the full gamut if you watch my videos. All right, number 15 says the following expression cannot be evaluated if a has a value of, and we can see our expression as a squared minus 4a plus 3 over a plus 3. The very first thing I want to do is attempt to simplify this expression. And in case it's not obvious, we have a quadratic equation in the numerator, and it has a leading coefficient of 1 here. And typically we can simplify those by factoring them like this. And now we're looking for two terms that multiply to positive 3 and add to negative 4. Well, that's going to be minus 3 minus 1. Negative 3 times negative 1 is positive 3. Negative 3 plus negative 1 is negative 4. So at this point, we can't simplify this any further, and we still have to answer this question. What value of a will make us unable to evaluate this expression? Well, what is this expression? At the end of the day, this expression is nothing more than a big fraction. And what do we know about fractions? Fractions that have a denominator of 0 are undefined. Okay? And I've mentioned this in my video on multiplication and division with positive, negatives, and 0. So if you have a 0 in your denominator, you can't evaluate the expression because it's undefined. If you have a 0 in the numerator, the answer is always going to be 0. So in this case, we want to find a value of a such that it makes our denominator 0, because that means the expression will be undefined and we can't evaluate it if it's undefined. So how are we going to make this denominator 0? Well, a plus 3 equals 0. We want to find out what makes this 0, so we're going to subtract 3 from both sides. This says a equals 0 minus 3, which is negative 3. So a for this problem cannot be negative 3. Otherwise, it will make our denominator 0, which means we cannot evaluate it. So that's the answer to this one. All right, number 16 says, if one of the angles of a right triangle is 40 degrees, what are the measurements of the other two angles? So let's go ahead and draw a right triangle very quickly. We know one of the angles in this triangle is 40 degrees. So let's call this one 40 degrees. A right triangle always has an angle that's 90 degrees. And so that leaves us with one unknown angle, which I'm going to call x. According to the triangle sum theorem, the sum of all the angles in a triangle is 180. So in a triangle, there are 3 angles. So that's angle 1 plus angle 2 plus angle 3 equals 180. Let's let this 40 be angle 1, this 90 be angle 2, and this x be angle 3. So angle 1, as I just labeled it, is 40, plus angle 2, which is 90, plus angle 3, which we called x, is 180. And now all we do is have to solve for x to figure out what this other angle is. 90 plus 40 is 130, plus x equals 180. Again, we're going to subtract 130 from both sides to get x by itself. This crosses out, leaving you with x equals 180 minus 130, and we can work that out very quickly. 0 minus 0 is 0. 8 minus 3 is 5, and 1 minus 1 is nothing. So we can see x in this case, which is this angle right here, must be 50 degrees. So the other two angles are 90 degrees and 50 degrees, which is answer choice B. All right, so that's it for this video. I hope you found it helpful. Admittedly, most of the problems were pretty straightforward, but that said, it really tested your knowledge of some simple concepts in mathematics, which the ASVAB almost certainly will. If you like the content I'm creating, please consider subscribing to my channel. In addition, you're more than welcome to leave feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose.